Hi, welcome to the second video in my Proof by Induction Inequality series. So as we saw before with Proof by Induction Inequalities, what we're going to first do is we're going to do the base case and assumption. We've then got the consideration case where we've got a bit more choice. We can pick one side of inequality. We next want to try involved assumption. So we're going to directly look for one of the terms in the assumption. That's going to inform us that inequality, we're not going to quite be there, so the rest of the terms that's different to our target, we're then going to look to prove that inequality, prove what inequality to do with that. You'll sort of see what I mean by this when we tackle this example, but usually this new inequality we have to prove is going to be a lot more simpler. It's going to be something we can maybe prove with a quadratic inequality, or a simple inequality like we saw in the first video. But anyway, let's get into it. So base case is always easy. We're just going to plug in n equals 5. So 2 to the 5 is 32. 5 squared is 25. And well, clearly 32 is bigger than 25. Next, we're going to assume true for n equals k, i.e. 2 to the k is bigger than k squared. Now we're going to consider n equals k plus 1. So we've got 2 to the k plus 1. So I said we could choose what side we want. It doesn't matter. I've just chose the left side because I've chose the left side. It's not super important, but you could choose the right side if you want, if that's what you prefer. Our next goal is to involve the assumption. So I want to somehow find 2 to the k in here. We've seen this trick before. We can rewrite 2 to the k plus 1 as 2 times 2 to the k. Well, now I can use this inequality. So this is bigger than 2 times k squared. So I've just replaced the 2 to the k with a k squared. So I've made it smaller. All right, now at this point, we're going to write our target down. So our target. That's where we just replace k with k plus 1. So our target is to show 2 to k plus 1 is bigger than k plus 1 squared. Okay, well I've got 2k squared. So I want to somehow find a new inequality that I've got to prove. So what I'm going to do is I'm going to expand this, just so I have a bit more information to be able to compare with this. So this is the same as k squared plus 2k plus 1. So if I want to make this similar to that, I'm going to split this up as k squared plus k squared. So you see how by splitting them up, they've become more similar. They share this term in common now. So what I need to do is I need a greater or equal sign and to show that this must be true. Because at that point, we're done. So I need to show that this is true. Now the only way I can do that is if I show that k squared is bigger or equal to 2k plus 1 for k bigger or equal to 5. Let's consider this quadratic inequality. So with all inequalities involving quadratics, we want to get our quadratic on one side. So we can get k squared minus 2k minus 1 is greater or equal to 0. Let's now plot this quadratic. So it's going to look something like this. We need to know its roots. So its roots are k equals minus b, so 2, plus or minus square root of b squared, which is 4, minus 4ac, which is plus 4, over 2a, which is 2. This is going to give us 1 plus or minus root 2. So this must be 1 plus root 2. This must be 1 minus root 2. And you can check this if you want. I'm sure your calculator nowadays has the polynomial root finder, so you can check this. But I'm sure you're probably familiar with the quadratic formula by now. Now, what does this tell us? Well, it tells us this inequality is true when k is bigger than 1 plus root 2 and when k is less than 1 minus root 2. Now, we only care about this section. So our inequality is true for k bigger or equal to 1 plus root 2. Oh. And here comes the crux, but k is bigger than 5, which is bigger than or equal to 1 plus root 2. So true. So it's true for all the numbers that we care about. So we can make our final conclusion that this here is bigger than this, which is equal to k plus 1 squared. So we're done. So we can write on the side here, so as true for n equals k plus 1 when true for n equals k, and true for base case n equals 5 by mathematical induction. Remember, write out mathematical induction in full when you do it yourself. It must be true. Be true for all n greater than or equal to 5. Remember, n has to be an integer, but we don't need to state that. That's kind of assumed in the question. But yeah, I hope this has been helpful. Remember, our goal with proof by induction for inequalities, we do everything as normal, base case, assumption. We consider one side, we try and involve the assumption, and then we're going to try make what we have look as close to our target as possible. Everything that's not like our target will then come into forming a new inequality. So we rewrit 2k squared as k squared plus k squared, because that made it look as similar to our target as possible. We don't want one of the k squareds, and we want instead 2k plus 1. So that's where we form our inequality between these two terms. And we had to show they're greater than or equal to for all of the k that we care about. But yeah, I hope it's been helpful. Thanks for watching, and I'll see you in the next video.